So we still continue with physics, radioactivity, as we continue to look at some sample questions on half-life calculation between 2020 and 2025 paper 1. So again, notice, what the question there says. It says iodine is a radioactive substance with a half-life. So they have told you the half-life of 8 days. Remember, the half-life is represented by Kasmoti and the half of 8 days. Then it says what fraction of iodine will remain after undergoing a series of disintegrations for 32 days, meaning the total time it takes to disintegrate is simply 32 days. So the question says what fraction. So now if they want you to find what fraction you need will remain, so if you want to get the fraction and they have not given you the initial mass that you started with, we apply the formula in this case. You can just apply NO, the initial that you have, or since they have not given us the initial, divided by 2 raised to the power n. Now this can also be written as 1/2 everything raised to the power n times that one. Now if they have not given you the initial, then the fraction that is just going to remain, we can just call this one in this case as what is going to remain your n. But if they just want the fraction, it simply means that you can just have it as 1/2 raised to the power n. So that will give you the fraction of what is going to remain. So we just need to find the number of half-lives. That's what we need. But you can apply this one when they have given you the initial to know what will remain at the end of it, as long as you know the initial and also the number of half-lives. But since the question says what fraction of iodine will remain after undergoing a series of disintegration for 32 days, so we'll just apply this formula is what you are going to be applying. That will give you just the fraction. So we just need to know how many half-lives are in that one. So to calculate the number of half-lives, you take the total period T, you divide by the half-life. So it is going to be 32 days. You divide by 8 so that you can know how many 8 are going into this total time they have given you. So of course 8 there will give you 4, give you just 4 half-lives. So that is going to be 4 half-lives. So when you get your 4 half-lives there, now you can now replace in the formula so that you can know the fraction. So the fraction now is going to be equal to 1/2 raised to the power 4. But of course 1/2 raised to the power 4 is simply a 16. So meaning the fraction that is going to remain after a total period of 32 days, that is going to be 1/16. So that is what you can use. So you always need to know the number of half-lives. How do you know the number of half-lives? You can get the total period that they have given you divided by the half-life, and that will give you the number of half-lives, and substitute it in that formula. Then you are able to use it in this case. Why I've not used this one here to know what remains, because I don't have the initial. Remember that N naught is representing the initial number of unstable nuclei. Let's try to look at another question that came in another exam so that you are able to see how you can go about it. Again, this question was saying that given that the half-life of toron is 52 seconds. So again, they have given us the half-life of the sample toron, which is equal to 52 seconds. Then it says how long. So how long will it take for the activity of the toron sample to reduce to 1/64 of its initial value? So how long, meaning that they want you to find the total period it will take for the sample to reduce to that. Now if you remember, that is just a fraction that they have told you. That is just a fraction they have given you, which is 1/64. So apply the formula in this case. So the fraction, like I told you, for you to get the fraction, it is simply, if you want, 1/2 raised to the power n. That's what we mean there. So the fraction there that they have given me is simply 1/64, which is equal to 1/2 raised to the power to the power n. Now, because both have got a 1, it simply means that I can simply just say 2 raised to the power n is equal to 64. That's what it simply means, because both of them are having, you know, a 1 on top. So you can just flip them. So when you flip them, it's like I'm saying 64 over 1, and that would be 2 raised to the power n over 1, and that will still give you that. That's what I told you. So just flip them. So now, how do I find n, in this case, the number of half-lives? Well, what we do, you can simply use your logarithms if you are doing additional mathematics, logs. But if you are not, you're doing just the ordinary science like it came, just get to and continue dividing 2 throughout until you have a 1. So 2 into 64 is 32, 2 into 32 is 16, 2 into 16 is 8, 2 into 8 is 4, 2 into 4 is a 2, and 2 into 2 will give you a 1. So when you reduce to 1, meaning that 64 can be written as 2 raised to, how many 2's have gone into this 64? You count 1, 2, 3, 4, 5, 6. So it is 2 raised to the power 6. So meaning it will be 2 raised to the power n is equal to 2 raised to the power 6. Because the bases are the same according to your laws of indices, then it simply means that the number n is equal to 6. So the number of half-lives is equal to that. Now remember, the question was simply saying how long. So for you to calculate how long now, meaning the total period, you apply the formula, the number of half-life times the the half-life. So you get that 6, you multiply by the half-life which they gave us, which is 52 seconds. So if you multiply 6 times 52, that is going to give you a 312 seconds. So meaning the total time it will take for the sample to come to 1 over 64 is simply 312 seconds. So that's what you need to remember. So 312 seconds is the final answer they wanted you to get. I hope you got a few concepts and you are able to use it so that you are able to calculate your question. Thank you so much. Watch out for some other videos as we teach you about how to write nuclear equation.